Hi guys, Algebra 2, we're looking at problem set 48 today, and this is dealing with radical equations. Now this term radical, what you need to think of is we're going to see square roots in our equation. Something that you need to recall is very recently we had lessons or problems where we had x squared equals some number, and we were asked to solve that. And our process in solving that was we isolated the x squared, and then we were allowed to square root both sides of the equation. And the reason we square rooted both sides was because the x squared and the squaring cancel each other out. They are inverse operations, and we got positive and negative, whatever the square root of the number is. Okay? So the idea here is the x squared and the square root, those operations are inverse operations. So keep that in mind. And what you're going to see on the problems that we're dealing with today in lesson 48 is our equations, instead of having something squared, they're going to have a square root in the function. Okay, that's called your radical. Now, to solve these problems, the process is very simple. First thing we're going to do is we're going to isolate the radical, which means we're going to get that square root by itself. So I want to get this stuff by itself. So to do that, follow your normal operations for solving equations, and that minus 2, to get rid of that, we're going to add 2 to both sides. So now we have the square root of x minus 4 equals 8. So the square root of some number or something equals 8. Now is where we need to remember that the squaring and square rooting are inverse operations. We need to get rid of that square root in the problem so we can get down to that x. So to get rid of the square root, we're going to do the opposite operation, which is squaring. Okay? Previous lesson we had x squared. To get rid of x squared, we square rooted. This problem we're going backwards. We have the square root. So to get rid of the square root, we're going to square both sides of the equation. Now it's important that you square the entire side. So I'm going to put this in parentheses. I'm squaring this side, and I'm going to put that 8 in parentheses, and I'm going to square 8. Okay, when you square a square root, they cancel each other out. So we are left with just x minus 4 equals, and on the right side we're going to square 8, we get 64. Now we have a very simple problem to solve for x. We simply add 4 to both sides, and we get x equals 68. Simple as that. Now, one thing we do have to do on these problems is we have to check our answer back in the original problem to make sure that it works. So if I go back up here to my square root, I'm going to plug in 68 for x. So I have 68 minus 4 under the square root, minus 2 equals 6. Well, if I take 68 minus 4, that's 64. And I need to check to make sure this works. Square root of 64 is 8. So I have 8 minus 2 equals 6. I have to verify that that is a true statement. 8 minus 2 is indeed 6. So that tells me 68 checks out, and it is a valid answer. Okay? So let's try another one. Again, the process, we're going to isolate the square root first. So here's my x plus 5 under the square root. I need to get that thing by itself. So my first step, I'm going to subtract 1. So I am left with the square root of x plus 5 equals negative 11 minus 1 is negative 12. Okay, my next step, I got the square root by itself, so my next step is I need to square both sides of the equation. Okay, again, squaring a square root cancels each other out, leaves you x plus 5 equals. Now on the right side we got to be careful. We need to include that negative since we're squaring the entire side. Include that negative, so excuse me, negative 12 squared. Negative 12 times negative 12 is positive 144. One last step to solve for x. I'm going to subtract 5. And so I get x equals 139. Now again, we have to double check this and make sure that it works out. Make sure that that is a valid answer. So I go back to my problem. I'm going to switch colors here. So we can check. Square root of, I plug in 139 plus 5 under the square root, plus 1 equals negative 11. Okay, 139 plus 5 is 144. Plus 1 equals negative 11. I'm a little concerned on this one. Square root of 144 is 12. Plus 1 equals negative 11. Does this one check out? If I continue on, I end up with 13 equals negative 11. Last time I checked, 13 does not equal negative 11. So that tells me 139 is not a valid answer. So I need to throw it out. So on this problem, we simply have no solution. There's no real number solution. Now you can write out no solution, or you can use this little symbol with the slash through it. That means empty set, or the null set, or no solution. Okay, make sure you double check your answers. It's very important that you plug it back into the original problem and see that it works. Okay, one last problem. This one looks kind of messy because we have an x squared and we got a bunch of stuff under the square root. Okay, so we just need to be very careful. Follow the same steps. So my first step was I want to isolate the radical. So plus 2 needs to go away. To make it go away, I subtract 2. That leaves this square root of x squared plus 3x minus 10 equals x minus 2. Okay, next step. We're going to get rid of the square root, so to do that, we need to square both sides of the equation. Now this is where it's really important that we square the entire side. If you look at the right side, we have x minus 2. When I square that entire side, I cannot just square x and square 2. I'm going to square this entire x minus 2. So that tells me when I square the square root, I'm left with x squared plus 3x minus 10. On this right side, x minus 2 squared, I need to take x minus 2 times itself, which means I need to use the FOIL method. And I'm going to multiply that together. So x times x is x squared. X times negative 2 is negative 2x. Negative 2 times x is negative 2x. Negative 2 times negative 2 is positive 4. Okay, if I continue adding like terms here, I end up with x squared minus 4x plus 4. That's on the right side. On the left side, I still have x squared plus 3x minus 10. Okay, now let's start getting some stuff together. I see an x squared on both sides. Normally, that's kind of makes it a more challenging problem when you see x squared and x. Probably going to have to factor this problem. But if you look at this one carefully, if I try to get these x squareds together by subtracting x squared from both sides, check out what happens. These x squareds cancel out completely. That's a good thing. Makes the problem a little bit easier. So I am left with 3x minus 10 equals negative 4x plus 4. Now this is a little easier to solve. I'm going to solve for x. So I'm going to add 4x. So now I have 7x minus 10 equals 4. Continue on a little bit further. I'm going to add 10 to both sides. So I have 7x equals 14. Last step, divide by 7. So I get x equals 2. Now again, we need to go back to our original problem, and we're going to plug in this number 2 and see that it works. So let me make some room here. Our original problem was, switch colors, square root of x squared. I'm going to put parentheses for x squared because I'm going to plug in a 2, plus 3 times x, which is 2, minus 10, and then plus 2 equals our x, which was 2. All right, so now we work this out. 2 squared is 4, plus 3 times 2 is 6, minus 10. All of that is still under the square root. Plus 2 equals 2. 4 plus 6 is 10 minus 10, which leaves 0 under the square root, plus 2 equals 2. Square root of 0 is 0, plus 2 is 2, so we end up with 2 equals 2. That's what I want. I want it to end up a true statement at the very end, so that goes back to this original answer. X equals 2 is a good answer, so we're allowed to leave that as a real number answer. Okay? So, steps in solving these radical equations. Isolate the radical first, then we square both sides to undo the radical, and then simply solve for x. Once you get an answer for x, make sure you plug it back into the original equation and make sure that that answer works and gives you a valid solution. If it doesn't, then you simply have no solution to the equation. Okay? That's lesson 48, radical equations. Good luck.